What's up guys, Major Math here with my first video for this series, Fluid Mechanics. My goal is to help you know everything you need to know to ace this class just like I did. For this series I will have a basic rundown of each chapter for this textbook shown on screen, as well as a bunch of example problems. For me, I believe the best way to learn fluids is just to solve a bunch of example problems, so my lesson will be short and sweet. Also, if there are any specific problems you need help on, I have attached my email in the description of all my videos. Without further ado, let's get started. What is fluid mechanics? The textbook says a subject that equips a person to solve engineering problems when the situation involves a flowing or stationary gas or liquid, which is also known as fluids. I don't think that's very helpful. It's pretty broad. My definition is these equations right here. So in this class, all it is, it starts with its hydrostatic equation, which you don't get introduced to until chapter 3. But it's this hydrostatic equation, and then you just keep building onto it until you get the Bernoulli equation, and then you build on to eventually get to the energy, equation until, and it is introduced in chapter 10. You don't really need to know what this means yet, but I'm just telling you this class is basically just these three equations for the most part. Chapter 1 is a lot about unit conversions, just getting really comfortable going in between metric and English units. Really useful skill. We'll talk about the grid method and some of my example problems. That's really helpful. And then also the textbook table F.2, F.1, one of those, F.1. Has just a ton of unit conversions on there. That was really useful, that I'll be showing in my videos as well. And then also just talks about the review of density. Density right here, that's how I write my row to represent density. So density is equal to mass over volume. It also introduces specific weight. Specific weight is just density times gravity. And then it gives you a little review on weight. Weight equals mass times an accelerant. And in fluids, it's often just that accelerant is just gravity. It also talks about the ideal gas law. In fluids, you usually use the ideal gas law just to find the density a lot of times. You can find other things, but usually it's to find the density. The important thing to remember when using the ideal gas law, or any version of it, is it's just really helpful to get in these standard units, because some of these unit conversions can get real tricky. It's always best just to put it in these standard units to really help you. You don't have to worry about it. You don't have to cross anything out. If you put everything in these units, everything will come out nice and clean the way you want. It also talks about some formulas like molar mass equals mass over the number of moles. The specific gas constant equals the universal gas constant over molar mass. And this is the universal gas constant right here. These are just useful when you're trying to manipulate the ideal gas law. You can use something like this to find R, or you can use something like this to find the number of moles. That's basically it. Thanks for watching, soldiers. Don't forget to leave a like and subscribe for more content like this. If you have any questions, leave it in the comments, and if you need help with any other problems, feel free to contact me with the email shown on the screen.